Now, so far, what did we see in Git is basically we first understood what is the workflow, how do you create a repository, and how do you do a change, and from that change, how is that you will share a change between people, how do you store it as a central repository, and then further we also saw the concept of branching, how we will be doing the parallel development, and then from that, how is that you are going to merge and share the changes between users in the central repository. And then we saw a couple of scenarios on if you want to take a backup or if you want to undo the changes, what are the scenarios and how do we move from one place to other place. So it's all more of the workflow, and from the Git perspective specifically on the user level we were trying to look. Now, coming to the next point, there are a couple of things which we need to understand. One, what we need to know is there is something called as branching methodology. So that is quite important that we need to know. And then talking about the management of the repository itself. So that is one thing that we need to at least have an idea of what it is. So before we get into it, now, if you remember, if I say a workspace in Git, it is going to contain three areas, right? So what and all are they? It is a working directory, staging directory, and or the staging area and the repository. So these are the three areas that we have in a workspace. And now, did we ever get back and see where exactly do you have all those things? So that is when now let us go to a workspace and let's try to see where exactly these three areas are. So for instance, now let's take this workspace. Okay. So in this workspace, if I'm trying to see, there is only list of files. So in this workspace, where exactly is the working directory, where exactly is the staging, and where exactly is the repository? So in that, what is the working directory? A working directory is a place where we will be actually seeing the files physically, right? That's what I meant. So that is the directory where you will be able to see the files and modify the files. So in that way, now this is the directory where I am able to see the files and modify the files. So pretty much this is our working directory of the workspace. Then where exactly is the staging area? Staging area is a buffer place which will not be visible, but where is the repository? Because repository is again a directory where you are storing everything. So all the details about when you modify a file, it is saying, and when you try to take a list of branches, the commit IDs, all those things, where exactly do we have in it? Am I audible to everyone? Hari, can you check your mic again? Okay, I'll be a little loud in case if I'm sounding low. So whatever that we were trying to store, if you look, it was actually in a repository with respect to the workspace. Now, in that case, where exactly is this information available in this workspace? Because if I go out of this workspace, I'm not going to get this specific to this workspace, right? So that way, where is our repository in the workspace? So in order to understand it, now, if you try to see the files, it will not be there. But if you use an option called -a to the ls, which will try to show you the hidden files, then you can see there is a directory called .git in the same directory or the workspace. Okay, so this is the Git directory, or this is the Git repository in which all the information of what we are trying to store, the commit IDs, branch information, everything is available. Okay, and the reason why is that we have it by the name called .git, because inside this, if you go, you will be having all the metadata required which will be acting as the repository. And if all these things was directly available under your workspace or in the working directory, and by mistake if you delete it, then it will not be treated as a Git workspace at all. So that is why, in order to separate in your workspace, where the default directory that you will be going inside your workspace is the working directory, and there will be an additional .git folder which will be treated as the repository. So this is how it will be classified, and this .git is going to be treated as your repository, and inside this you will be having all the details. So the objects, whatever that you're seeing, is the folder which is going to track all the commit IDs that you have. Okay, and then the head is nothing but the head reference of where we are currently pointing to. And configuration is a file which is going to store the details about from where you have connected, all those things, for example. So here, if you see, it is clearly saying that this is your origin, or this is your central repository from where we have taken, and in that what and all branches we have, and what is it a reference. Okay, so that is how it is going to track each and everything inside a .git folder, which will be treated as the repository. So be clear, .git is the Git repository for your workspace, and this directory itself will act as the working directory. So that is why you are trying to see this. Now, the same thing, let us go to the central workspace or the central repository. Okay, so this is my central repository. And in this, if you do a ls, do you see any similarity between what you have inside the .git folder and what you have here? It's kind of same, right? So what is the difference? Now, the difference between the bare repository and a non-bare repository. So what is the difference between a bare repository and non-bare repository? Can anyone quickly tell that? What is the difference between central repository and a local repository? Or what is the difference between a bare repository and non-bare repository type? Why do we call this as a central repository? Why do I call this as a local repository? No? You guys forgot? Yes. So in the central repository, we will only store and share, whereas in the local repository, you will try to store and share as well as you will modify. Okay, so that is the point now. In order to modify, you need a working directory. Okay, so only with the help of working directory, we were able to look at the content of the repository. Now, when you say that in the central repository, you are not going to do the changes at all, that simply means that you don't have a working directory at all. That is why, since we do not need or we do not have a working directory in the central repository, the contents of whatever you have in it is directly put inside the workspace. Whereas in our local repository, we need a working directory as well as a Git repository. So that is why you are going to put the contents of the repository into .git. Whereas in the central repository, there is no working directory. So you don't have to create one more folder called .git inside it. So directly you can put everything. That is the reason why even if you try to do some changes, you will not be allowed. That is because you are actually directly working on the repository. Whereas in the local workspace, repository will be put separately inside a .git folder and you will have a working directory. Okay, so understand that is the difference why it is called as a bare repository or central repository, because it doesn't have a working directory at all. Okay, so whatever you see is nothing but the content of the repository directly. Now, if you say central workspace or central repository, it is both one and the same. Because in the bare type repository, you do not have a working directory at all. Getting it? Is that clear? And why do we call it as a bare repository? Now, by saying it, so far, what is that we did? Now, all the workspaces that we created so far, where was it available? Now, if you look, all the local workspace or all the central workspace that I had was available in the same directory, right? Now, when you go to an organization or in a production, it will not be like this where this workspace may be for one user, this might be for another user. In that case, this workspace will be available in his laptop or in his machine, and this will be available on the other user's laptop or on his machine. Like this, each one of them will be available on his own machine, and the central repository now should be in such a place where they will be able to access it from all the machines, right? Because if I am working, I am creating it. But what if all the five of us are working? I cannot keep this in my laptop. So I have to keep it in a common location where we have to access or we have to give access to all the people. So one way that you can do is you can have a separate machine in which all the five of us have access, and in that machine I can create this directory, and whenever we are doing a git clone, I can refer to the directory available in that particular machine. But instead of doing it, which is going to be a time consuming process and you need lot of authentication to be given, one of the simplest way that we can use is GitHub. So what exactly is GitHub? GitHub is actually a place, or simply it is an online place for storing the Git repositories. Now, instead of storing the repositories on your machine or a particular machine, you can store the repositories online. So that now, if you want to do a clone, rather than referring to a machine in which a directory is available, you can refer to this online place called GitHub in which you can store. Okay, now it gives you all the freedom where you don't have to be dependent on one machine, and at the same time you don't need any specific access for that machine. So directly you can go to GitHub, and from the GitHub you can allow people to connect to that repository or do a clone of that any point of time that you need. So that is how it is going to be simpler in terms of the process and also for maintaining. So GitHub is actually a free place which is been given by the GitHub where you can store the repositories. But as an organization, if you see, it is not possible to use the free space, because whenever you say free, then there is a catch that is going to be public where anyone else can access it. So that is when, if needed, by default, GitHub will be giving a free account where you can store. But if not, if you want to keep the repositories privately, not to be shared with anyone, then you can buy a particular location in GitHub using which we can try to ensure that place is private. Okay, so that is one of the things that you will be doing. Or in some companies, they might be working on some other tools. So we have tools like GitLab, or we have tools like Gerrit, where that is another tool, just like how you're saying GitHub, where you can store all the repositories. Ultimately, no matter what kind of tool that you are using, you are going to use it only for storing. Whereas from that, whatever user commands or whatever the git commands that you have to work will be the same on your machine. The only difference that will be is, rather than keeping everything under one machine, you put it into this place like GitHub or GitLab or Gerrit, where it will be maintained separately. But in that way, GitHub is completely available online. You don't have to store anywhere else. Whereas the other tools like GitLab or Gerrit is actually another tool which you need to install, and then from that you have to create a web access from that particular location you are going to store. So in those tools, you can actually think about giving the permissions for the users, saying for this repository, who and all should be allowed to work, who should not be allowed to work. So those kind of changes can be done on top of that tool. So depending on the company, which tool that they have to use or which tool they have to choose depends particularly on their need. But if not, a common place to store is GitHub because it is completely available for free. So if you go to the GitHub, first you have to make sure that you have an account created. Okay, so if you do not have an account, use a Gmail ID and create an account. Okay, and then once you go inside it, you will have a private place where you can store all the repositories that you want. So here you can see that if you want to create a new repository, you can create, or an existing repository, you can push to it. Now in my GitHub account, I have two repositories available. So as an example, if you see here, I have some set of files that I have put, which is actually a Maven based Java project. Okay, so now anything that I'm going to store, instead of storing it in a machine, it will be coming up here. And now, how is that you're going to access this? Specifically, if you're accessing through GitHub, then this has a path which you will use, and that path will be like this. So simply now, if you want to refer to this as a central repository, then you have to do the clone based on that. So if you want to do a clone, how do you do a clone? Git clone, and you have to give the path of the central repository. So instead of giving a physical path, you are trying to give a path on the GitHub, where anything that is storing with .git is actually a central repository. And where is the central repository available? It is available under the GitHub under a account called My SEM Learning Center. So that is how, using this central repository available in the GitHub, we are actually going to create a clone. So now let's say I'm going to create 05. So it is trying to access the GitHub, and from that it is trying to do a clone. So you can see this is the same that I have over the GitHub online. So like this, I can choose this online place to store. So here, what is that we did? We created this workspace as a user. So any changes that you want to do, you do it here. And from this, when you do a git push, it is always going to refer to the origin of this or the central repository, which is this one. So like this, the only difference is from where you are trying to do the clone is the difference. Other than that, a user will create his workspace, and his machine on that workspace, he'll be using the normal git commands, and he'll be trying to do the changes, and then he'll be trying to push the changes from his local workspace to whatever is the central repository that he has used. Okay, so that's the major difference, where GitHub is an online place for storing our repositories rather than storing everything in our local repository. So pretty much now you can create your own account, and any repositories for Git that you want, you can try to upload into it and maintain, so that if you want to share it with someone, you will just give the path of this particular repository so that the user can directly do a git clone from this, and he can get all the changes. So whenever he wants to modify and push, he'll be pushing back to it, or if he wants to update the workspace with his latest changes, then he will do a git pull. So everything is going to work with respect to this workspace, which is available online on the GitHub. Okay, so this is going to give the complete details about how many commits has been done, how many branches you have, okay, who and all has been done the changes. So everything is clearly, this is just like how I am seeing my commit details inside the central repository through command line. We are trying to see everything using the GitHub account. Getting it? So like this, depending on what kind of tool that you want to use, you will not be actually storing everything on your machine or on a particular machine. So it is from the users, they will be trying to create a workspace on their machine, whereas to store, you can think about using some online storage like this, like GitHub, which is available for free, and you can upload everything to that location. Or you can purchase a location and try to put everything online on this GitHub. Getting it? Any questions? Here, you all have the option. So go back to your GitHub account, create a new repository, and it is going to ask you for the options where either you can create first an empty directory as we did, you can initialize the repository, or if you already have a repository, you can use it to update. Okay, so simply you're going to say what is the name of the repository and what is the type of the repository, whether it is a, okay, so here you just give a name, test repo. Okay, and I want this to be public repository because anyone can access. Now, do you want to put a initializing by giving a readme? You can do. So this is your new repository. So if you go back now, you can see that I have created one new repository. And if I want to share anything to it, I'll use this as the account. So simply in this, instead of working on this, if I want to do a git clone of this, I'll say git clone of this and test. So now using this as a central repository, it is going to create a clone of your test. And inside this, now you see, you are just going to have a README file, which will give you the details what I have stored when I create it. So this is what I have, nothing else. So going forward, if I do any changes in it, I will first do it in my local repository. And from here, I can push and update it to the central repository. So that's the difference. So you can directly create a central repository, and from this, you can have a reference. Okay. So now there is one more advanced topic which is out of the scope, but at least I'll give you an overview of what it is in Git. Now, one thing what you need to understand is now Git you are going to use only for managing the commit IDs. If a user wants to work, and how is that you are going to prevent authentication on who should be working and who should not be working? So that is how, as I said, you will be using some tool like GitHub. So if you have an account into it, you will be able to access. Or pretty much if you go to organization, you will be using some tool like GitHub or Gerrit, using which you will be trying to log in, where to that tool, you will be integrating your LDAP. So I'll talk about what is LDAP in later session. But for those who don't know what is LDAP, LDAP is a utility or a server where you will be allowed to log in with a single username and password to many machines. So now when you go to an organization, you will be doing the same thing where you will be having one account, and using that one account, you will be trying to log into all the machines. So that way, now whatever the tool that you're going to use on the backend, you will be trying to associate that particular tool with your organization's LDAP. So then if you try to log in, you will try to allow to log in only if you have an account in your organization's LDAP. If not, you will not be able. So that way you will make sure who has to log in. But now, if anyone who is working in a company will have an account by default, that will be available in the LDAP. But if you want to restrict on who should be working on this repository and who should not be working, so those kind of advanced options is available only on any of the tool. Okay, actually I have not connected. I'll try to show you in some time. on how is that can be done. So those kind of advanced options where you want to take care on giving permissions. Let's say only Adam should be doing a push to it. No one else should be able to do a push. So how is that you're going to restrict those kind of authentication? So those kind of things can be done in that tool. And in addition, if you want to implement some process, then there is something called as triggers or hooks in Git. So what exactly is a hook or a trigger? Basically, it is nothing but a simple script that you can use in which you can try to put some process and you can apply that script to a particular command. So that way, whenever you are running any Git command, you will run that script which is called as hook or trigger, and based on what validity or any functionality or process that you want to implement, you can apply it using that. Okay, so one example that where you can use is, now like I said, every commit needs a commit message. Okay, so that way now if a user is giving a message, you do not know whether he is giving a right message or not, or even if he gives one space and enters, it will be taking it as a message. But when you're working as a project, you want people to enter some proper meaningful message, or in organizations, you will be actually having something called as a bug tracking tool, using which the QA or the developer will be trying to write the details on what changes they have done. And with that only the management can track what exactly is happening to a particular release, whether the development has completed it or whether testing has been done. So like that, whenever a developer or a user is trying to give a commit message, he has to make sure he is giving that ID against which he's trying to work. So every bug will actually have one number, that is what we call as ID, which will be used to track, so that you will know what is the purpose of that and what you are trying to achieve and for which release you are giving. Now, rather than giving all the details, you can just give only that bug number against which the user is modifying the files. So if you want to make sure that that is mandatory, then you can write a script which will try to take the message before it is going to do the commit and validate whether the message is exactly as what you wanted, and only if it is there, allow him to proceed. In case if it is not, you can make sure that you will try to stop your commit command and give the message to the user saying that, hey, the message that you're using to commit doesn't have the proper syntax, so try to give the details which is required. So like that, you can try to set up a process. Okay, or there could be some times where before the release, you would like to make sure that none of the developers are going ahead with any new changes. Because while we are doing a testing, if a developer modifies a file in between, again, you have to take that and do a testing. And in case if there is something which he has caused is going to be a problem, then the testing will also fail. So that is how in the organization, before doing a testing completely, once all the development activity is completed, they will basically ensure no more new check-ins or commits should go into that repository. So how will you make sure that? So that is one way where you can write a script and say no one should be allowed to do. So anyone who is trying to write or do a git commit or a git push, then it should be giving a message saying that you are not supposed to do a git push. You can go ahead and create a commit in your workspace, but you cannot do a git push. So like this, these kind of things can be done on top of a git commit command or a git push command. So that way, those are called as hooks or triggers or wrapper scripts. So what kind of script that you can use? Simply you can use a shell script or a Perl script or a Python script, anything which is based on your operating system on which you are running the git command. Okay, so that way, if you go into any one of the workspace, okay, and if you go to the git directory, which is .git, in that you can see a folder called hooks. And if you go inside the hooks, you will be seeing certain files, okay, where these files are the sample files which the Git is giving us. So now, when you are trying to apply a hook, which is nothing but a script, you can apply it to a particular command in two ways. That is, whether you want to invoke that script before executing the command or after completing the command. Okay, so that is what we call it as pre-step or post-step. So pre-step means as soon as you enter a command, you want to make sure that first the script is triggered, that is the hook is triggered, and it will try to do some validation, and if everything is fine, then it will allow you to proceed further. That is one. If not, the other one that you can do is after that command is completed, then you can try to call a script which will take care of some activity. Like, let's say for every commit, you want to get a message to be notified. So you can set the mail. So what you can do is simply now you can set a script which can act as a post script or a post hook for a command, wherein after the command is completed, you will call that script automatically, attach it to that command, and it will try to run the script. The same thing if you set it as a pre commit or a pre hook, then before you run the command, it will first run the script, and then everything is fine, it will go ahead with the actual command. So depending on what is your scenario, you can do. Okay, so I'll just quickly show you an example of what we can do. Now let's say in this I want to apply some rule where I want to do a commit, and before a commit, actually I'm trying to run a script, that is a hook. So that way, the name of the script, what you are going to put inside it, should be the command followed by the pre or post. So if I am interested to write a script which is going to be applied for the pre-step of a command called commit, then I have to put a file inside this folder with the name pre-commit. The same thing, if I want to run a script after completing a command, then I will say post-the command. Okay, so now whatever that you're seeing here is a sample file. So if you rename this to this way, let's say pre-commit sample to pre-commit. Now what it is going to do is, now whatever the content that you have will get invoked whenever I call the commit command, and then this is the first thing that it will execute, and after it is completing, it will proceed further with the actual commit command. So like this, before doing a commit, I can validate certain things. Okay, now to just test, I'll try to edit this file. Okay, so you can see this is nothing but a simple shell script, nothing big in it. Now here I'll try to write a message. Okay, now simply I'll try to add one condition, and I'll say if okay, let's not do first, let's understand that it is getting called echo pre-commit okay. I've just put one line. Now this is a simple script which they have given, which is actually not going to do anything, whereas internally I'm trying to put one command. So now in this workspace, if I try to do some change and call a commit command, now to that commit there is one a pre-commit hook or a script which has been created. So what will happen is, the first thing that it will do is try to run the script, and only if it is allowing, it will proceed further. Okay, so let's come out of this, and in this, let me quickly create a file. Let me do a git add, and let's do a commit. So now, as soon as you call this, it is not basically going to do the commit directly. The first thing that it is going to do is, it is going to call the pre-commit hook, because I am invoking a command called commit, and for that there is a script called pre-commit. So the first thing that it is going to do is it is going to call that script, which is the hook, and then based on what you have given inside it, it is going to execute, and only then it is going to proceed further. So you can see the first thing that it did is it is checking whether it is having any hooks, and there is a hook called pre, which means before you are executing the commit command, the first step that you have to do is call this. So it is calling, and since we didn't do any validation as such, it is completing it, and after completing, it is proceeding with the actual command, whatever that you have entered. Okay, so like this, you can try to set up the process of whatever is needed for your organization in terms of pre or post a particular command. So all you have to do is just say pre and what command you want to apply if you want that script to be called before the execution of that command. The same thing if you want the script to be called after you have executed the command, then you will simply say post and the command name. Okay, so like this, whatever is the need for you to do automation of any process or authentication, you can do it. Now, once again, if you are using any tool like GitLab or Gerrit, they have these kind of options directly in it. So rather than you taking care of all those things, you can try to set up a hook directly in that tool where you're trying to store the repository. Okay, so those kind of advanced options are also available in those specific tools. So that's why people use the administration perspective, whatever you have to do on those tools, whereas the normal use case that as a user they will be using the regular workspace. Okay, so remember, you can do those kind of authentication and creating a process about who should be working, who should not be working, or when to do a command and when not to do or execute a command using the hook scripts. Okay, so that's one thing that you have to remember as an advanced concept. In case if you have a necessity to do, you can simply do it. So now, if you try to compare Git with any other tool, you can literally see the differences on what we are working. Now, one of the tools that you will be comparing with Git is Subversion, because Subversion or SVN is again a free tool. Okay, so that way, now the major differences between the tool that we are going to have compared with the Git is, first thing is in Git, everything is distributed, which means every workspace will have its own repository. So whatever that changes you are doing, you have to do and store first in your workspace or repository, and then from there you will be trying to push it to the central repository. And then second thing is speed, because your workspace is going to have a copy of your repository, so pretty much any changes that you're doing will be fast enough in that itself. And also talking about branching, since every workspace has its own repository, you can create as many branches as you want and store everything and merge. You don't need someone else to do that, because in other tools like Subversion, the branches will not be available in your workspace. Branches will be available in the repository, which is available in only one place. So anything that you have to create, first you have to create in the central repository, and you will just refer to it from your local workspace. Whereas the advantage of that in Git is you will be having everything as a copy of the complete repository inside your workspace. Okay, so that's the advantage on why people start using Git, especially in terms of automation, lesser maintenance, and it's easy for the developers to take care of their workflow. Okay, and that's why one of the reason importantly that we use Git in DevOps automation. Getting it?
Hi Adam, this is Hari.
Yeah, Hari.
Hello, can you hear me?
Yes.
Actually, the GUI which we are getting it from GitHub. So can't we get the same GUI from our system, like a central repository?
Yeah, this is an open source. This is nothing to do with
Yes,
your machine. It is online. I am trying to connect it through online. I have not installed anything. This is an
yes, yes,
online tool, just
yes.
like Gmail. So do you have to install anything for Gmail to access from your laptop? No, it is available online, right? That way, all you have to do is, if you can create an account on GitHub, then you can log into it and access, just like Gmail. So GitHub is an online storage for Git repositories.
Yes, I said this I understood, but I wanted to get the same GUI from the system from my system which I have installed Git. So can we get it?
Yeah, go to github.com. You can access it. I am not accessing it anything specifically my machine. This is the github.com site. So just go to the github.com site. That's what the example I'm trying to give. Now, if I go to gmail.com, does it mean I have installed anything for Gmail? No, I am trying to access it through web, right? Same way, if in your laptop, if you want to access Gmail, you can just go to the URL and enter. So that is how GitHub is also something available online. You don't have to install. All you need is, if you have an internet connection, then you can try to connect to that GitHub online, because it is an online storage.
Ah, uh, yes, I had actually this I understood. This you are accessing from github.com. Just I wanted to access same like this kind of GUI from my server, like where I have installed a Git. So can we access? Can we?
Now that is a question. What do you mean by your server? Your server means your
No, that
laptop.
means no. Yes, suppose if I am using my laptop for to install a Git, so it is called as workspace. So whenever, so I wanted to access the same kind of GUI from my workspace.
Yeah, then go to github.com URL. That is it. See, you are installing Git command for running the Git operations. So whatever that you have installed here, this, it is for running the Git commands. But in order to access the repository online, then go to this particular site. So that is what I'm trying to say. So from your machine, if you want to store something on the GitHub, then make sure that you have internet in that connected to that machine or laptop. And from that, if you can go to the URL and give http github.com, it will be trying to connect to it. So the only thing that you need is internet on that machine. If you have internet on that machine, you can connect to it.
Okay. Okay.
Getting it?
Yes, yes, sir.
That's why I'm saying compare
And
it with Gmail. So now, if I show you that I am logging into Gmail, does it mean that you cannot log into Gmail? You can log into Gmail. Only thing, you should be having an internet connection on your laptop or your machine. So if you have it, it is good enough. The same way, GitHub is an online place. It is not a tool. It is an online place for storing your repositories.
okay, okay. And later we will be going to discuss how we will integrate Git with LDAP. Am I correct?
Which one?
No, LDAP. So I wanted to manage the users for accessing purpose with the LDAP as you told. So that
Yes.
how we are going to integrate with the LDAP.
That depends, that you need to work with the IT team. Now, what tool that you're using, that pretty much differs, because this is one of the example, but I'll show you an example of GitLab, how we are using. But for working it, you need to go check with your IT team, and you have to get the details, like what is the LDAP server, what are the details of the LDAP server, and then you will attach it to that tool. So that is going to be something specific to each company. So every company will have their own tool, or they can directly use the GitHub itself. So depending on what kind of tool they are having, it is going to be separate in specifying it. So I'm just giving you an overview that in case if you are using any other tool, then what is that you're going to do is, you will try to make use of LDAP, because in some companies you will also not be using LDAP. There is also something called as AD. Okay, now if they are using anything like that, the concept simply here is, in company, you will not be allowing users to create separate account. there will be one common account which will be created. That is what we call it a single sign-on. So for all the machines, they will be giving you one account. So you will use that account to connect to your laptop as well as to connect to different machines or applications where they will integrate whatever the mechanism that you are using with that tool with other accounts. So that is how with one account you will be able to connect to everything. Now to do that, you need to first understand in the organization how you have set up that single sign-on. So you have to work with the IT team and then try to do the same thing for whatever application that you're doing.
Okay. Uh, okay. Actually, what I was asking is, so is there any option to integrate directly with some server where we can give the directly LDAP server name? From
Yeah,
that it will take. Okay. Go ahead.
we have, but like I said, it depends on how your organization is trying to say. Again, I'm not saying every company will be using LDAP. LDAP is one of the option. Now, like LDAP, you also have something called as AD. They will be using that also. So depending on the company, what kind of mechanism they are using to ensure one common account. That is what you need to know. And second thing is how they have set up. You have to check with the respective IT team or the engineering team, or that is the engineering support team, and trying to find out how is that you can ensure the same thing for this tool. So they will give you the details about this is how we have done. You take the same details and put into whatever tool you want, and then if you add those things to the tool, it will be trying to take care of the authentication. Getting it?
Okay. Okay. Fine. Yes. Yes. Thank
What I want you guys to do is create a GitHub account for yourself. So go to the github.com, try to create a account by signing into it. And then so far, whatever that you are practicing, instead of keeping the central repository in your machine, try to put it to the central repository on a GitHub and then try to do a Git clone of it, do the changes, try to push to that and pull to it. Because now anything that I push from here or pull will be going to the respective central repository from which we have created this, which is be on the GitHub. So that is the difference. Rather than having the central repository on the same machine, try to put it on your central GitHub that you have. So that is how, if I use some other laptop and if I want to access this, all I have to do is use the repositories path which the GitHub gives, or with respect to a tool what path you're getting, you just try to use this and do a clone so that whenever I'm accessing, we'll be accessing this repo available on the GitHub or the other tool. Okay, so first try to practice it. The only difference is rather than keeping everything on your machine, you will be trying to put it under your GitHub. Okay, so depending on whether you don't want to give any money, then go with GitHub. Suppose if you want to give some money and maintain the tool, that is when you will be going with the other tools that I showed. So GitLab is actually a enterprise tool where you have to pay money for maintaining that also, like purchasing a license. The same way, if your organization is thinking about not giving any license more or specifically not to spend money, then they will be going ahead with the free account like GitHub where you can store everything. Getting it? What will happen once the developer does all these things? So the next thing is, if you are moving ahead on the release process, you will have to give these changes to the QA to do the testing. So when they are going to do the testing, how is that you are going to actually give these code what we have written and pass it on to the QA? Okay, so for that, the next concept that we need to understand is what we call it as build management. Okay, so let me try to. Okay, so before we jump on to the concept of the tool, let's first understand what exactly is build management. Okay, so what is build management? As I said, after the development has been done, that is, after they have written the code, Now, pretty much in order to give it to the QA, you have to create a product, and that product, whatever that they are going to use, and for creating it, whatever steps that you're going to do is what we call it as a build management. Or in simple words, when you're trying to create a product, you call it as building a product, or simply we call it as a build of that project, or a software build. Software build means you are creating a product from the program whatever the users have written. But in that, what exactly do we do? So basically now when a user or a programmer or a developer writes a program or the code, so we call it as a source code. Source code means the source from which you are going to create a product. So all these Java files or C files are considered as a source code for a project. So when you're actually doing a build, what happens internally is these Java files or the C files, which is the raw source code that we have, will not be understood by the machine. So the first thing that we have to do is convert these raw source code that we have in format of the Java file or C file into a file which a machine can understand. Okay, so that process where we convert the program files into a machine understandable file is what we call it as compilation. Understand this? Compilation is a process where we convert a raw source code into a file which a machine can understand. So that is how for each program that you write, whatever that we see the content, it is actually a raw format or a raw source code. So now the first thing that we have to do is we have to convert each and every file that we have in our project correspondingly into a file which a machine can understand. And that file is what we call it as compilation. And pretty much each of the file that you are trying to convert into a machine understandable format is what we are going to call it as object files. So first you are going to have the source code. So for example, you're going to have 1.java and you have to convert this 1.java into a file which a machine can understand. Okay, so pretty much now those files which you convert on each of the file is what we call it as an object file. And this process of converting the raw source code into object file is what we call it as a compilation step. Okay, so like this, every program file has to be compiled where it will be trying to convert from the raw source code into an object file. Okay, and that is the very first step of our build management, where we will be doing something called as compilation or compiling. Compiling means in our project, whatever the raw source code we have, we will convert each one of them into a respective object file which a machine can understand. So the object files will be differing from what kind of program that you have. So in case if you're writing your source code in Java program and if you try to compile it, then you will be getting a class file which will be the object file. The same thing if you're trying to write a C code, the source code will be 1.c for example. And if you try to do the compilation step for this, you will be getting a file called 1.o. So like this, depending on the program, you will be getting an output file which the machine can understand. And this file is generally called as object files. But specifically, the step where you do this is called as compilation. Okay, so like this, the first step in your building the project is compiling. Compiling means converting all the source code into a machine understandable format. Okay, that is the first step. Second thing, when we convert these files, is it the only file that we'll be having? No, I said in your project, how many other files you have to convert everything into a specific object file, because each of the source code is going to have some functionality. Only with the combination of all those things, you are going to create a project. Now, let's take a simple example where we are creating a project for calculator. Okay, let's say the project what you're creating is actually a calculator app. Now you write 4 files where in one file you will try to write the program that will try to do the addition. So let's say you will actually have a file called add.java, and then you will be having something called subtract.java, and then you might have one more file called divisible java, and then if you want you can have something like this where using each of the file you will be able to provide the functionality. So now when you do the compilation for each of them, you will be getting a corresponding object file or a class file. Okay, so this is how the first step that you do is compilation. And then once you have created, now are we going to use it separately? No, because when you say a product, everything whatever is necessary has to be put together and assembled as one single software. So if you install any software, are you taking files separately inside it? Because after installation, if you go to that particular directory under your program files, especially in Windows, you can see that it will have multiple folders and then it will be having multiple files inside it. Now, are you going to install it separately? No. Basically, when you install, you see one executable or one deliverable file, which could be a zip file or a tar file or a exe file, which you try to install it, right? So that is how out of these files, you are going to combine everything and then create one particular deliverable. That is the actual software product that we are going to use. So that way, now out of all these things, you are going to assemble everything. Okay, so whatever the different components that you have, and out of that, you are going to create one single deliverable. So like this, now either you can have one deliverable or multiple deliverable depending on how many functionalities that you want to give. But simply building is all about first doing a compilation step of converting all your raw source code into an object file, and then from that creating a single or a multiple deliverables wherein each of them will be having all these files inside it. So that is how when you run this, with respect to whatever that you have inside it, you will be trying to get a particular functionality. Okay, so that is what we call it as the build step. So build step means you will be having two actual process and steps. The first step is compilation and the second one is assembling them. Okay, now why do you actually need something called as a build management separately? Now if you look, it is not just one file or few files that we have. In a project, there could be hundreds to thousands of files. Now, if you are trying to create a project, you need to know what and all are the dependencies of it, how exactly you are going to do, which file you have to do first, that is, which file has to be compiled first, which file has to be compiled next, and for creating a deliverable, what and all are the files which you have to combine and create a deliverable. So as the number of files gets more and more, and the process also for creating a product that is built will also get complicated. So that is when we cannot keep doing all those things manually every time, and remembering all of them will be difficulty. So simply what we can do is we can think about doing an automation of whatever that we have to do in such a way that by just clicking one command, you can able to do all those things automatically. So such kind of automation, what you are trying to do to automate all the process of compilation as well as creating the deliverable by assembling them, is what we call it as build automation. Okay, so build automation is all about automating the process of creating a build for a project, which includes the compilation automation as well as assembly to ensure you create one or multiple deliverables. Okay, now at this point of time when you're focusing on DevOps, you don't have to just think only on doing the automation for compiling and assembly. Whatever that we are going to do, we have to think as a release process. So that is when the build automation can also take care of doing some automated test on top of the binaries that we have created. Okay, the binaries or deliverables. So many people will call it with different names. They will call it as a deliverable or binary or a package. Everything is going to be referred to the same, which is nothing but the actual product that you have created. So now you don't have to just constrain ourselves for the build automation only to do these two things, but if needed we can also think about running some automated test once you have created the build, and then if needed you can also take the same files and do the deployment to a particular system, which could be a production system or a test system. So like that we can think about extending the automation to do various levels or steps that we need as part of the build automation. Okay, so that is why it is quite important as of now to understand how you're going to automate, because from a developer he doesn't have to focus on wasting time and all those things. He can just use one utility where as soon as he has changed with respect to what he has changed, what and all files he has to create, that is compile and build the product and do the test, everything can be done using build automation. Okay, so that is why build automation is the another area which is quite important, where we will be trying to reduce the time of the developer as well as the QA, and also ensure that the release process is going to be smooth. So now as part of our build management, whatever deliverables that we are going to create is what we will be giving it to the QA. Okay, so that is why every organization has to focus and will be focusing on this area, where for all the projects that you have and all the files you have to create a build automation which will take care of all the files for that project and do the build. So that way, now how is that you are going to do a build automation? Now a build automation can be done by simply writing any script, because whatever I said, it is all some kind of steps. So for this there is a command that you will use, and for doing this there is a command. So you can just put all this command into a script and get the things done. But as the complexity of the project keeps increasing, it is not easy to write a script and maintain. So that is when, as of now, for doing the build automation or for handling the build, we have specific tools which are called as build tools. Just like how we have SCM tool to take care of the version controlling, we have a tool which will be used specifically to take care of all these build activities, which are called as build tools. Okay, so that way the next topic that we are going to understand and learn is one such build tool called as Maven. Okay, so before that, understanding, or did you guys get what exactly is the build management and why is that we are supposed to do the build management, and in that what is that we are going to do, as in at least an overview? Others, is that clear before I get into it? Okay, that's a good question. So when is that you are going to do a build? Now, whenever we want the product to be created and giving it to the QA. So when is that you're going to do? Now, every day or at particular point of time, you have to decide saying that we now have done all the changes that the QA needs. So once the development team says that we have done all the work, so that is when you will be having a lead from the development side or pretty much from the release management side who will be tracking, saying that, hey, this is the actual product or the change which we have to give it to the customer, and that have we done all the development for that. So that way, whenever the development activity has been completed, or when we have all the changes done by the developer for which a functionality has to be tested, then we will go ahead and do a build. And for that, now at that point of time, you will go to the central repository and take a particular commit on which you have all the other commits following it. So that way, now once you have that particular commit in which you will be having all the latest files, using that commit ID on a workspace, you will do this actual step of build and then create a product and give it to the QA. So commits will be done by the developers as and when they complete the change, but you decide when you have all the change that has been done so that you can create a product out of it, and then you go ahead and do the build, wherein it is not just only to give it to the QA, where how is the developer is going to do a testing of his change. Now, if a developer has modified a file called 1.java, how is that you are going to test it? So he cannot directly test his 1.java because 1.java is just a raw source code. Once again, even he has to do a compilation of that file called 1.java to 1.class and then run that 1.class and verify. So that is how even a developer, to do his testing or verification, he has to basically go through the build step or compilation, where he will not be creating the complete product. He will be creating only the component, whatever his change is going to be considered. So that way, a developer also has to do a build to verify whether his changes is creating that particular component of a product. And now when you go to the QA, you accumulate all the changes like this, what we have done, and you will be using all the changes together and create the product. So that is how, using this build tool, if you want, you can create only a single component which a developer will be using it for testing, or he can use, that is, we can use the complete files and create the whole product and give it to the QA. So that's the comfort level where you don't have to do all those things manually. So you write a build tool or use a build tool in such a way that you can create based on certain files, either one component or all the components or the complete product as it. Getting it? Okay, so like this now, as I said, focus only on the developer part first. Let's come back to the release later. But now, regardless of whether he's a user, that is a developer, or a QA, if you want to create a build of your project, you need to do something, that is build automation. What is that you have to do is what we are going to see. And later on, we'll come to the process on when you will be doing this build, how exactly you will be doing all those things as part of your release is next thing. But first, now, after you have created the file, how is that you are going to create a product out of it or a deliverable? And for that, we are going to use a tool called build tool, which will help us to do all the steps that is needed. Okay. So now, one of the tools that we are going to use for doing the build automation is Maven. Now, to understand Maven, the first thing is Maven is actually a build tool specifically for Java projects, which means Maven is used to create a product based on Java files only. You cannot use Maven to build a project against a C file. Okay, so Maven is specifically for Java based projects. So if you have Java based projects, pretty much in this market now, you will be using a tool called Maven. Okay, so remember that. And the second thing is Maven is a free tool, or it is an open source tool given by Apache. Okay, so actually we call it as Apache Maven because Apache is the organization which has given this tool called Maven, and it is an open source tool, which means it is available for free for us to work. And the third thing is Maven is also built on Java, which means Maven is used for Java projects or is used to build Java projects. And then the next thing is Maven is an open source tool, which means it is available for free. And then Maven runs on Java, which means now if you want Maven to be installed and run internally, Maven uses Java to run. So that means now on your machine, if you want to install Maven, then you need to have Java on that machine so that Maven will use Java and run the project for Java. Okay, so that's what you need to understand. So Maven is created on Java. In fact, Maven is nothing but a tool which is created using Java programming only. So it runs on Java and it is used to build only Java based projects. Okay, so that's the first thing that you need to understand. Now, why is that we are focusing only on Maven? Because if you look at the projects, almost all the organizations are moving their programming languages to Java, and that is why we are trying to understand a tool which is most popular in the market based on the programming language which is more popular. Okay, so that way if a question comes what project that you are handled, you are actually handled a Java based project, and in that you are going to use a tool called Maven. So that way Maven is actually a project management tool, which means it is not just a simple build tool, but it is a combination of various features that you will be seeing it on different tools. So assume this way, if you had 4 to 5 tools, in that you will be having separate functionality depending on the tool. Everything put together as one single tool is what we call it as Maven, because it is a superset of various features found in various other tools. Okay, and that is why we call Maven as not just a build tool but a complete project management tool. And using this Maven, we can do much more things beyond build, and you can actually manage the complete project. So what and all it is going to do, that is what we need to understand. But specifically, if you're looking at Maven, how is that it is going to take care of our complete project management? So basically, it is going to use the object-oriented model. So just now we know that Java means, basically we call it as OOPS. OOPS means object-oriented programming. Same way, when I say Maven is built on Java and it is going to run on Java, Maven is also going to use the same concept of object oriented, and that is how it is going to treat your project. So basically it is going to treat your project or split your project into smaller and smaller components, and each component that you have in your project is going to be treated as an object so that it can easily handle. Okay, so in that, if you are using Maven, no matter how many projects you are using, it will be following a single standard across all the projects. Okay, so remember, if you are working on Maven, we will be following a standard. So whether I can use a project or I can use another new project, or wherever company that you go, you will always follow one standard when you are using Maven. And next thing is the life cycle of your development. So after doing a build, how is that you are going to do a compilation? How is that you are going to do a packaging or assembly? How is that you are going to do the test? What you have to do first? So all those things will be a big confusion. So that is when, if you are using Maven, along with the set of standards, it will also give us a defined life cycle. Life cycle means it will tell us what we have to do first, what we have to do next in a proper order and a sequence. So if you are working on Maven, then along with the set of standards that we are going to follow, we will also be going through a defined life cycle. Okay, so we will be doing in terms of phase by phase, phase one, phase two, everything will be done in an order. So remember, if you are using Maven, along with the standard, we are going to follow a defined life cycle. Okay, then Maven helps us in doing a dependency management system. What do you mean by dependency management? Since Maven is going to treat our project in terms of object oriented, now whatever is the dependency of a project in terms of a libraries. So generally when you say a project, for working on that project, you might be requiring many library files for it. Like a Java project might be requiring many library files. So simply when you are using Maven, we don't have to worry about all the dependency, because if you're using any other tool, you have to take the burden of telling what and all are the dependencies for the project, what and all are the libraries that you need. Whereas if you're using Maven, the advantage is Maven will take care of the dependency management, whatever is needed for the project. That is another advantage. Okay. So by using these three things, Maven is going to take care of our complete project. That is by treating your project as a object, and then it is going to give a set of standard, and it is going to give us a defined life cycle which we are going to follow. And top of that, it will help us by taking care of the management on the dependency completely. Okay, so by using all those things, it will be taking care of a complete project management. So that is why we call Maven not just as a regular build tool, but as a complete project management tool. Getting it? So if you have understood it, for today, I'll just explain few more things and I'll stop. And now when you are working on Maven, whatever instructions that you are going to pass to a Maven will always be in terms of something called as goals. Okay, so now if you are invoking Maven against a project, you will actually give something called as a goal. So that goal is nothing but the particular part of a life cycle. So what is that you are interested to do? So for that project, my interest is to compile. My interest is to create a package or a deliverable. My interest is to do a testing. So like that, what exactly you want to do to that project is what you're going to instruct through something called as goals. So remember this word, anything that you're going to instruct to Maven will always be a goal. So with respect to that goal, it will be trying to do something. Okay. Now, internally, how is that you are going to do something in terms of goal? So if I tell to Maven, you try to copy a file or you try to compile a file, how does it is going to do? Where for each goal that you are passing to Maven, it is internally going to call something as a plugin, where plugin is nothing but a specific file using which Maven will be actually performing a goal. So that way, for each action that you want Maven to do, there will be a plugin associated. Only with that, it will be trying to do. For example, if your goal is to compile, then when you say Maven compile, then corresponding to the compile, there will be a plugin specifically which it uses to invoke the compilation step. If you want to copy a file, then you will specify a goal as copy, where for that copy, it will be having a specific plugin which it will be using to run the copy command. Or if I say create a deliverable, then it is going to basically give the name of the goal. Let's say I will say create a deliverable, and that is my goal. For that, whatever the plugin that is needed, it will be trying to use. So specifically in Maven, we are going to use different kind of plugins and achieve a particular goal that is needed. So that is how what we will tell to Maven is the goal, and every goal will be associated to a plugin which internally Maven will call and perform a action. So this plugin is what exactly going to do a task. So remember, when you're calling Maven, you will be actually giving Maven something called as goal, and that goal will specifically call a plugin, and that plugin will actually do a task which is needed. Okay, so try to understand this, because going forward, the next session, whatever that I'm going to talk will be in terms of this goal and plugin. But pretty much we will see what exactly are the goals that we are going to use in Maven so that we can get a task done in the Maven project. And now, simply to compare Maven with any other tool, the advantage is Maven is not just a single build tool, but it is a combination of various features available in different tools. And next thing is, it is going to give us a easy build process, because you are going to follow a defined life cycle. So no matter what kind of project you are going to work, you are going to follow the same life cycle. So it will be easy for us to work on the system. Same thing, it is not just the life cycle, you are also going to follow a standard. So that way, no matter how many projects you are creating, you will be always following a standard, because of which all the build system that you are going to have for different project is going to have a uniformity. So when you say everything is going to be similar, then maintenance will be easy, right? So that is why the reusability and maintenance is quite easy in it. So that if you create one project using the files that you have done for that project creation, you can reuse it for creating a new project. So that is the advantage in Maven, where it is very simple, you can reuse the project, and it is easy for maintenance because you're following a standard and you're going to follow a defined life cycle. Okay, getting it?